Now for example 5, we'll see that the factoring involved at the beginning should be a little bit easier, but it's just going to produce something a little bit different, and we'll find out as we go along. So we've got f of x equals x squared plus x minus 6 all over x plus 2. I'm going to factor the top. Two numbers will multiply to negative 6 and add to 1 are going to be plus 3 and minus 2. X plus 2 here. Nothing cancels, so I'm not going to have any holes. And we'll go from here. Vertical asymptote, there's going to be 1. That's going to make our life a little bit easier. Vertical asymptote at negative 2. So I'll quickly do my test points at negative 2 and or 2.1 and negative 1.9. That would be just to the left and just to the right of my vertical asymptote. Put in a negative 2.1 and adding 3 is going to take me to the positives. Minus 2 is going to get me further in the negatives. And then the bottom is going to be an interesting one. Negative 2.1 plus 2 is not big enough, so it's going to stay negative. That'll give me a negative on the top, negative on the bottom, so that's going to be positive infinity. Let's go off and graph my asymptote so I can do this right now. So I have an asymptote at negative 2. And I did a pretty good job at hitting negative 2. I'm just going to have to move it over a little bit. Good. And apparently from the left-hand side, I have it going down to negative infinity. Oh, sorry, no, positive infinity. Let's test negative 1.9. Adding 3 is going to take me to the positives. Minusing 2 is going to keep me negatives. And then adding 2 is going to take me over the positives. That'll give me a negative on the top, positive on the bottom. That's going to be negative infinity, and that's going to go off to negative infinity. So if you need to pause and get caught up on that, you can. But we've done lots of this practice, so hopefully we can move on to the interesting thing that's going to happen in this particular question. And that's going to happen when I look at the horizontal asymptotes. So looking at the horizontal asymptotes, the degree in the top is 2, the degree in the bottom is 1. So that means that n is bigger than m. So the bigger number is going to be on the top. That means it's going to go off to infinity, which means that there is going to be no horizontal asymptote. So that's great. So there's no horizontal asymptote going on here. However, you've probably noticed that n is bigger than m by 1. So that means we're going to have our first look at an oblique asymptote. So there's going to be a diagonal line here that's going to behave like an asymptote, and this graph is going to come really, really close to, but not touch. Question is, how do we figure out that oblique asymptote? We actually figure out the oblique asymptote by doing the division that this question suggests. Remember, all rational functions is a top number divided by a bottom number, right? A polynomial on the top divided by a polynomial on the bottom. So we're going to actually do that division and see what we have left over. So I'm going to do long division and synthetic to show that both will work. But you see I have a top number, which is x squared plus x minus 6. And I'm being divided by a numerator, which is x plus 2. Doing my long division really quickly, what do I multiply by x to get x squared is x. Mini rainbow, x squared plus 2x. Subtract and I get negative x. Then I start over, what do I multiply by x to get negative x is negative 1. Mini rainbow, oh, I forgot to bring down the minus 6. Brock would be all over me for that. Multiply by negative 1 is negative x minus 2, and I subtract, and I get a negative 4. Now I end up with a remainder, which actually is good, because if I didn't end up with a remainder, that means it would have factored and something would have canceled up here. But I do have a remainder. That's fine. The remainder is not the important part. The important part is what I'm left over with. The quotient, this spot right here, is your oblique asymptote. The quotient is going to show me that oblique, or that diagonal line, that's going to get me the oblique asymptote. If you want, you can see that I have done it with synthetic as well and gotten the same result. The answer is x minus 1. So that means there's going to be a diagonal line, and the line is x minus 1. X minus 1 is an easy function to draw. It's a linear straight line. Its slope is 1, and it's going to go through -1, y-intercept of -1. It's down 1. So I have this spot, and then up 1 over 1, up 1 over 1, up 1 over 1. It's y equals x. That's easy, but down 1. And so I'm going to end up with this diagonal line like this. All right, so here's my first example of oblique asymptote. Now I've got to get a little bit more information. All I have is what happens at the horizontal asymptote or the vertical asymptote. I need a bit more information to get a more accurate graph so I can get my y-intercept and my x-intercept. So I'm going to quickly do that. The y-intercept is when x equals 0. Go back to my original and just plug in 0. So that'd be 0 squared plus 0 minus 6 over 0 plus 2. Is -6 over 2, which is -3. So there's a y-intercept at -3. So 1, 2, -3, y-intercept. X-intercept is going to happen just as easily. The x-intercept is when y equals 0. And I'm going to use the factored version of this. So I just need to scooch up so I can see it. X plus 3 x minus 2 all over x plus 2. It's much easier to see the x-intercepts here. So you know the bottom's going to multiply by 0. So it's going to simplify. It's going to disappear. And you'll see I'll have two x-intercept. An x-intercept at -3 and a second one at 2. So the -3 is going to be over here, 1, 2, -3, and the next intercept at 2, so 1, 2. And now I'm getting a better idea and picture of what this is going to look like. Unfortunately, because just like horizontal asymptotes, I can't put in negative or positive infinity to tell if it comes from above or below. I'm just going to have to use experience. I'll have to wait for calculus to do that. Similarly, nothing up here or here, so I don't know if it comes from above or below, but I can use my practice and my experience. Look at what I can see. I can see the graph is going to go through this x-intercept, and it's going to go off like this. So I have a feeling it's going to come down, go like this, and start to go close to this oblique asymptote. Graphs can cross oblique asymptotes just like they can cross horizontal asymptote, but at the extremes, it's not going to cross. And on the other side, I can take all my information. I see it goes down like this. It has to pass through this point and this point. Chances are it's going to rub up against the asymptote over here. So I'm going to have the graph come and do a similar shape over here. And I have that graph. Hopefully then you can see an example here now of where the oblique asymptote comes into play and how valuable the other information is, the x-intercept and the y-intercept, plus your experience to know that the graph looks like this. Very quickly, what if I had a different situation? Same intercepts, well actually this one's got different asymptotes, excuse me, and different intercepts. Well, again, I'm going to take the information I see and draw my graph. If it's going to go through this intercept here, and this intercept here, this intercept, and go down, then I think it's going to go something like this, and then get close to this oblique asymptote. And from experience, I know that if it does it on this side, it's probably going to do something similar over here. And I've got that information. So it's a matter of taking your oblique asymptotes, your vertical asymptotes, all your information, plus your x-intercept to make a very educated guess on what the graph will look like. And now that you've seen these two, you can put that experience into your memory bank and be able to draw similar graphs when you come up with similar information.